Here we will see the Gini impurity. Okay, Gini impurity, the concept of Gini impurity is the same of the entropy concept. We have already learned the entropy. So the Gini impurity, this concept is almost similar. This is the almost similar to the entropy concept. But the questions is why we need to learn this thing. If these both the things it's similar, then why we need to learn? Then the question is why we need to learn this. So we will find this answer after end of these discussions. So before that, please I request you, please be patient. Just see these discussions first. Then after that you can automatically find its answer. Why these things is more important than entropy. Okay. So this the formula of the Gini impurity is like Gini impurity of the variable y, its formula will be like that: 1 minus summations of I is equals to 1 to k. If we have k category for the random variable y, and then its probability of the yi and its square. This is the simple formula of the Gini impurity. This is the simple formula of the Gini impurity. Okay, don't be confused. Ig of y and Ig of y for a features. This is totally different meaning. This Ig means information gain. This Ig means information gain. And this Ig means Gini impurity. This is the totally different thing. Gini impurity and information gain, totally different concept. Okay, don't be confusion. Just write down this thing. Don't be confused. This is totally different. Okay, now let's take in our discussion, let's take we have two variable. I am just omitting our y is the k category. We have just for our sample set of our discussions, we have taken our for random variable y, we have two category. It is y plus or it will be y minus. We have only two category for this discussions. So suppose let's discuss this thing case by case. I think using the case conditions, it will be better to understand, sir. It will be better to understand. So for case 1, let's take probability of the random variable y equals to y plus. Let's first this probability is let 0.5, and the same thing is also for y minus. Let's take the occurrences for both the classes same, equivalently probable, equally probable for occurrences for this y plus class as well as y minus class. Both the class occurrences will equally probable. So in such scenario, we have seen that if the category occurrences of the category is equally probable, or it is simply a uniformly distributed. If a random variable is uniformly distributed, in such cases our entropy will be what? Our entropy will be, we have seen already, our entropy for these cases is 1. And similarly, if you just calculated the Gini impurity, so what will be the value of the Gini impurity in such cases? Just calculate it. So this probability square means what? 0.5 square plus also 0.5 square. This will be 0.25 plus 0.25. I think this value will be 0.5. Okay, so we have got that our entropy is 1, but our Gini impurity is 0.5. Now let's discuss the another case. So in this cases, probability of the random variable y for the category y plus Let's take its probability value is 1 and the another probability will be 0 is 0. Let's take these cases. It's one class, we give the total priority, we give the all priority for one class and we have totally neglected another class here. Just see this thing. In this scenario we have already seen that in this scenario our entropy will be what? 0. And what will be the Gini impurity? Let's count it. So our Gini impurity will be 1 square plus 0 square. This thing also will be 0 here in such cases. This thing also be 0 in such cases. So entropy is also 0 and as well as our Gini impurity is also 0. Just see this thing. First I am taking the equally just I am taking the equally preferences for each classes. Equal preferences I give, but in second cases I give all the preferences for one classes and I am neglect the another classes. Then in such cases we have seen that our Gini impurity is 0 and in first cases we see that our Gini impurity is 0.5. So from this we have seen that our maximum value of the Gini impurity is 0.5 and the minimum value of the Gini impurity is 0. That for our maximum value for entropy is 1 and the minimum value for entropy is 0. That we have seen, but in Gini impurity this value is 0.5. This is the main differences. Okay, so if we have two category, that is y plus or y minus, then the probability of a class y plus is what? 1 minus probability of y minus. So if you just draw this picture, then you will get, if you just draw this picture, it is our probability of y plus and this is the sample entropy value or Ig of y. Here I am using the Ig of y in different color. Yellow color I am using. Gini impurity I am using different color and I am using the blue color for entropy. Now we will see this is sample 0 value, this is sample 1 value and this is 0.5 value. This is 0, this is 0.5. Suppose let's take this is 1. This is 1. Now first draw the actually we have already seen the our entropy will look like this. The graph of the entropy is look like this. When it is 0.5 then its value is 1 actually. And after that it is decreased its value. Okay, we have already seen this kind of picture. So here it will be stop here. This kind of picture. And the picture of the Gini impurity will be like that. It is the 0.5, its maximum value. First it is increased, after that it is decreased. Like that, this picture. So the yellow picture is for Gini impurity of the random variable y and this picture is for entropy for the random variable y. Now if you just see here, if our in this region, just divide this region in two portions. This is the first region, this is the second region. Okay, just if you see in this region and what happening in these regions, our probability of y plus value increased. and as well here our entropy value is also increased, and our Gini impurity value is also increased in this region. You see this green region here, deep green region here. This region means I'm talking about this region. Now let's see this region. I am using this color, orange color. Now see this orange region. Okay, so in these regions our probability value for the class y plus is decreased, sorry, increased. This value is increased, but the main thing is that its entropy value is decreased in these regions, as well as Gini impurity value is decreased in this. Okay, just say this thing, the both are the same kind of. I am also just start of this lecture, I already told that the Gini impurity concept and the entropy concept, both the thing is same, but now see the main differences here. So the if you just see the formula of the Gini impurity, it will takes the square term. But if you just first write the formula for what is actually the formula for entropy. So the entropy formula is minus of, actually what we are calculating to calculate the entropy, we are calculating minus, we have calculated the entropy minus probability of y plus and log of probability of y plus minus probability of y minus log of probability of y minus. This thing we are calculating from the for calculate the entropy, and for calculated the information for Gini impurity we are using this formula, 1 minus probability of y plus a whole square y minus a whole square. So just see think here we are using the log. Okay, here we are using the log formula here, log formula. And if here only we have two category, but if we have k category, then we have to compute k log value, k such kind of log value. So because computing the log is more computationally intensive than the computing square. So just write down this thing. Computing the logarithm is more computationally intensive. It's more computationally intensive than the computing square. Because of this region, this we can, in generally we cannot calculate it the entropy value, because both the sims are actually work the same. The work actually for both the importance, the work actually for the both are the same, but main advantage for information Gini impurity is that its computational power is higher than the entropy, because computing logarithm is more computationally intensive. Here we have to use more computational power to calculate a log instead of calculating the square. Because of only this region we neglect calculate the entropy. We are using the concept of Gini impurity. This is the main advantage of the Gini impurity. And if you just see some library, if you just recall the Python, they have a very famous library, sklearn. They have a very famous library, sklearn. They, instead of using in entropy concept, instead of using entropy, they are using the Gini impurity, because it is the computationally efficient. They are used this, their preference this. They are neglected this this entropy concept, because Gini impurity is more computationally efficient than entropy. Because of this reason, only because of these reasons, we prefer Gini impurity, nothing else. I think the importance why we have to learn the Gini impurity, I think it is clear all of you.